All right, good day and welcome back to Everything Mathematics. And today we are going to continue our series on logarithms. And we are in a series of completing the various rules that abides when doing logs. And today it touches to touch on rule 3. I personally usually see rule 3 as one of the most dynamic rule or one of the most powerful rule because it really paves a way when it comes to solving really complicated logarithms. It sometimes helps you to solve or sometimes simplifies a question where you could easily or get closer to the answer. And it's also one of the main three ones, the one that we did. Of course, we started the day before with rule 1, then we look at rule 2, and then we look at rule 3 today. These first three rules are basically the general three rules that abides logarithm or under logarithm. There are other rules, but these three rules are what are generally considered as the prime ones or the main ones, if to put it like that. So rule 3 states this: if you have log of, let's say, some base a to, let's say, some x raised to the power of what? Let's say y. Rule 3 tells us that we can send this y, the index, we could send that up to the front. As a result, we could end up with y of log ax. And as simple as this looks, sometimes by just doing this, you could see the whole pathway to the solution of a question. So this is basically rule 3. And of course, you have to acknowledge the opposite is also true. So if I have something like, because sometimes you have to do the reverse, and that's where sometimes we get blinded. If I have k log b raised to what? Some letter, let's say m. If I have something like this, you also have to be able to see the reverse of this. You have to be able to see that this is actually the same as log of b to the m raised to the k, which is also a fact. Good. And this is one of the rules that usually is just a means to an end when solving a problem. When you do that, then the next thing you could do, of course, is simplify or find some other rules or apply some other rules. Because as I said, no rule when it comes to logarithm, pretty much none of the rules work in isolation, to be truthful with you. Each rule has its whereabouts in which it can apply or be used with another rule. So let us see how this rule could come in handy when solving a problem. So supposing you get a question like this. So supposing I give you something like, let's say, log of 4 of 5 squared. Well, let me not use 5 because, I mean, you go see 5 and then you say, oh, well, you could just square the 5. But for the purpose of this video, let's use n plus, we have something like maybe log of 4 to, let's say, m. Good. And if you're simplifying this, and again, as I said, I'm only doing this to apply the rules. Supposing they ask us to expand this or write it in a single format or whatever the case might be. Or in as much as we can easily, of course, just keep this n squared here. When it comes to simplifying a question, sometimes it comes on to bringing it forward. In this one, honestly, it doesn't call for it, but just to show you the rule. So here you could bring the 2 in front, and of course, we will end up with 2 log 4 of n plus log 4 of m. And notice this 2 now becomes like a, how you call that, a coefficient. So this 2 is actually being multiplied by this entire entity here. You have to take note of that. And not necessarily the whole, the log 4n. That has nothing to do with it. It's just this here. And from this point here, of course, we could go back and apply our rule 1, which will look something like this now. 2, and again, log 4 of n times m. And this 2 still remains outside there as a constant, as a coefficient. And that's what this could do. This one doesn't help much because, of course, it doesn't solve anything here. But let's look at one where maybe applying this rule will help us to solve a question even better. So let's look at something like this. Supposing we have something like let's say log x squared is equal to, let's say, log, let's say 5, not 5, let's say log 6. Good. And one of the things you need to know here is that this log here and this log here are of the same base. So as a result, they have the same, well, not just the same base. When the base is not present, I think that is what I should say. Of course, they're the same base. We could see that because there's nothing in both of them. But the generalization when it comes to log is that if there is no given base, it is understood that this is to base 10. Good, so it's base 10. So technically, there is a 10 here, there's a 10 here. But it's understood, so there's no need to put it. And applying this log, remember, using a calculator, we could easily solve for log 6. But I'm not going to solve. I'm going to leave it just like this, just to show you that how the rule is basically applied. So here we could easily bring these 2 in front, and that will leave us with 2 log x, and that would leave us on this side over here with some number. I don't know that number, and I don't want to calculate. As a matter of fact, I could calculate it. Let me make our life. Let me see if it's a nice number. I'll write it down. If not, I'll just use algebra. All right. So this one has a decimal. So I don't want to use decimals. You know, it's something point something 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 go down there. Right. So, but just imagine we could use our calculators and get a value here, an entity here. So let's call that B, for instance. So that's B. Good. And once we have this, now the 2 that is in front, guess what? Simply finding the sub of the formula. We could simply divide this side here by 2 now and divide this side here by 2. And that will leave us with something such as log x is equal to b over 2. Remember, I am let log 6 equal b. Maybe I should write this for the purpose of those that might be watching and you just pick up this video halfway and you're wondering what are b doing there. So I'm just letting b be equal to log 6. So whatever log 6 is, it just will be b. And in this case, it's a decimal value of 0.777 go down the line. 77 something 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 go down the line. So notice, now we have a case where we have log x is equal to b over 2. And this here is a lot more simplifiable than if I would have had the x raised to the 2 as a log. It would have been a lot more complicated because it's not a simple matter of like when we were doing with algebra, we could have said maybe, oh, okay, to get rid of a square, you just find the square root. But no, this is under log. So you can't just do that to get rid of the square. But you see, that's how powerful I say rule 3 is. But by sending these 2 in front, you put the 2 in, let's say, a vulnerable position where it can now be equated for a certain value. Of course, I wouldn't go further here because, again, we don't know. Well, we know what is B, but yeah. But I just want to show you how the application of this rule can enhance solving a question. Let's look at another scenario. Supposing we have to simplify, expand something. Imagine they ask us to expand. And this one is pretty straightforward. I think I'll stop with this one. If they ask us to expand and they give us something like this, log 5 of, let's say, in bracket here now, we have x cubed n squared all over, let's say, y to the 4th. Yes, and this again, it looks very cumbersome. This might look like a very complicated problem. But understanding rule 3, along with the other rules, by the way, notice this question, to be honest with you, this question here will apply the 3 rules that we learned starting from rule 1. Yes, this question here has all 3 rules up to the one that we're learning today. If we have to expand this, of course, first thing we have to be able to see here is that we have one base, 5, and we have something as a rational, or a fraction. At the top, notice that we are products. We're multiplying x cubed with n squared, and we're dividing that by this. So the first procedure here is to separate each log. The top will be addition, and the bottom will be subtraction. So this is the same, really and truly, as log 5 of x squared plus log 5 of n squared minus log 5 of y to the 4th. So this is basically what the log is, what the expansion is. But we ain't done yet. Notice we still have everybody with an exponent. So now we do our rule 3, in which we could just send all the exponents in front. So we have 3 log 5 of x plus 2 log 5 of n minus 4 log 5 of y. And this is as far as we could go in this question. So again, I trust this helped to at least just understand the rule, which could bring us back to the first slide. The rule simply states if we have an exponent, we could send the exponent to the front. And if we already have it in the front, we could actually revert it if needs be when solving a question. And what we did today is basically just apply the various rule. Tomorrow, God willing, I think to wrap up this week, we will do various questions where these rules are applicable, and we might probably look at some questions where you have to solve and not necessarily just simplify, because you need to understand that log is a number. So you could actually solve a log. The log doesn't always end up with an expression. All those that have been doing so far, we ended up with expression because I just want to emphasize a rule. I'm not focusing on solutions, but the solution is basically just wrapping up, finishing up the question, like bringing it right to the end, which you will easily be able to do once you know the rules. So this will be the ending of today's video. Again, as always, feel free to like, share, and subscribe. And until the next one, you do take care. And of course, if you have any question, feel free to leave it in the comment section below. You take care.